Hello friends, today we are going to discuss the assignment number 10 from dealing with materials data collection analysis and interpretation course. So let's go to the first question directly. So a study was conducted to understand the effect of temperature on process yield of a chemical process. The average percentage of process yield is linearly related to the process temperature. So the set of observation is given in the table below. Temperature in degrees Celsius and process yield is in percentage. Okay, they have given temperature versus process yield data. They are also telling it is linearly related. So like this, there might be some scatter, but they almost follow a linear trend. So okay, so they are asking us to fit the least square regression line. So this is a kind of least square regression line. This line it's like averages out the errors and they give a estimated straight line. So for that the general equation is y is equal to um, alpha plus beta x. So alpha and beta are regression coefficients. Then that we have to find it out here. So alpha is the slope of that slope, sorry, beta is the slope and alpha is the intercept. So if we find these two values, then we can form an equation, linear equation. Okay, so how to find it out? Let's first thing is like first we have to find the for finding the beta, the formula is beta is equal to covariance of x and y divided by variance of x. So it can also be related like sigma of, sorry, not sigma is the standard deviation, s of xy divided by s of xx. So whatever be the variable, dependent variable here. So here to find the covariance, this is equal to beta. To find the covariance, we know covariance is the difference in the difference from the mean in x into difference from the mean in y. So if we sum this entire component, for that first we need to know what is the mean x bar. X bar is a x mean, that's 675. I have already calculated from the given data. X bar is 675 and y bar is 55.55. So you just have to plug in each and every value from the given data, and you have to find the covariance value. So covariance value, what I found is 1 yeah, it's 118. So this is population covariance divided by n. So 1182.5 divided by, okay, sigma x square is 2065. So 20625. This is sxx. From this we can find the beta value. So once we find the beta value, the alpha value is simple, that alpha is equal to y bar, which we already know, minus beta, which we have calculated right now, into x bar. So from these values we can get the alpha value. Alpha is close to 17.13. Yeah, so answer is this one. Okay, let's go to yeah, we have found the alpha and beta, so answer is done. So let's go to the second question. The second question, they have asked the least square simple linear regression model. In the model, they're asking which of the following assumptions regarding the error term epsilon. So this is the error term epsilon is correct. So the error term epsilon error term means how much it is deviating from the regression line. So the expected value is zero, because like we have to the best fit is when we have zero error. So the expected value of the error term is zero. That is the assumption for error term we have given initially. So let's go to the third question. Okay, they are asking like ya is the response of an input value xy. Okay, ya is a response variable, x is the independent variable, and the least square estimator is the regression line equation. The sum of the square of the residual is equal to. So sum of the squares of the residual is given by response variable minus a is a estimate unbiased estimator of alpha, and minus b into xi. This is the unbiased estimator of beta. So it's like difference of the squares. So and the random error follows a normal distribution with a variance equal to sigma square. So the error follows normal distribution with sigma is equal to, sorry, mean is sigma is 0, and sorry mean is 0, and variance is equal to sigma square. Then what type of distribution is followed by the ratio of sum of the squares of the residuals and sigma square into sum of the squares of the residual. So here whenever it comes to the sum of the squares of the variance, the we have already seen in the previous discussions, they generally follow the chi-square distribution. So here also it is a chi-square distribution with n minus 2 degrees of freedom. Yes. So fourth one, if the hypothesis beta is equal to 0 is considered for a simple linear regression model defined as y is equal to alpha plus beta x plus epsilon, which of the following conclusion is correct? Okay, when beta is equal to 0, then y just becomes alpha plus epsilon. This is expected to be 0. The expectation of this is 0, and generally the regression curve might look like just a straight line, doesn't which means it doesn't have any relation. It is always going to be constant. So there is no relationship between x and y. This is the answer for the fourth question. Okay, let's go to the fifth question. Here they have asked in A and B are the unbiased estimator of coefficients alpha and beta of a linear model. Yi is the okay. Then estimator B of beta follows. Okay. So first we have to understand what does B depends on. B depends on beta. That is very obvious, and uh, beta forms the mean for the estimator as well. So from that, how much it deviates is the standard deviation. Here we have to give. It is given by sigma square by sigma square is nothing but the sigma x y generally divided by that's covariance divided by sxx. Or generally, it is given by population population variance or covariance. So to find out what distribution it follows, we have to see the residual. Residual is the difference in the observed value and predicted value. So if you see that response variable whatever we have got from the experiment minus the predicted values, we can see there is a y is the normal distributed value because it has taken from the population, which is a normal one, and the predicted value also should be normal distribution in order to match this relation. So a and b should be a normal distribution, should also follow a normal distribution to satisfy this equation. Okay, then which means like it follows a normal distribution. So any three within this, and as we have seen, its mean value is close to beta. So beta. So this is the answer for this. Let's go to the sixth question. A study is conducted to estimate the removal efficiency of air pollutant particles from air after the rainfall. The percentage of decrease in pollutant particle concentration before and after the rainfall measured during the different times of the year is given in the following data. So with increase in the rainfall, you can obviously see the decrease in the pollutant particle. So what they're asking is like find the least square estimate of regression coefficient beta for a regression line. So just like that, just like what we have found before, here also just we have to find the covariance of this covariance of x and y. There is nothing but s of x y. I already have found these values. Since it is a simple math, we can do, because the covariance of x and y is nothing but like x minus x bar, sorry, sum of x minus x bar into y minus y bar by n. Okay, then we have to find the response variable variance and independent variable variance 3.68. So once you find all these things, just you have to substitute in the equation, just substitute in the formula. B or beta is equal to covariance of xy divided by um, variance of the response variable. Yeah, here variance of the SYO is given by 100. So SXY is given by 18.93 equal to 0.189. That's given here. It's a simple question. So followed by the sixth question, there's one more question. They both are interconnected. So we are asking, using the given data in the question number 6, calculate the 95% confidence interval for beta in regression line. Okay. So for whatever we have found is the fitting to the regression line, we need two coefficients alpha and beta. So those things only we were finding it out. Now they are asking, using the given data like what I have seen in the previous question, you have to calculate the 95% confidence interval. So within which the 95% of the data falls. So okay, so how to find it? Already we know whatever. Okay, so 1 minus a here it defines the 5% confidence interval, 5% significant level. So a is a significant level, just like alpha, whichever we have used before. So confidence interval for estimator of beta is given. The estimator of the beta is given by b minus, like plus or minus only, square root of sum of the squared residuals divided by sum of the squares of the residual divided by n minus 2 into variance of the independent variable. So okay, so here what we have to find it then, already we have already we have the following details, like sorry, here it is a response variable, by mistake. So here we have to find sum of the squares of the residual. Apart from that, we already have sxx and variance of x. Then and also we have to find the t value from the t table. So these two things we have to find it out. B already we have found, beta we have already found from the question number 6. So, and we can call that value and we can use it here. So to do this, sum of the squares of the residual is given by variance of x into variance of y minus covariance of x by the whole square divided by variance of x. So when we substitute all the calculated values in this, we will get sum of the squares of the residual as 0.101. So when we substitute all these values, then the first one more thing what we have to find is find the here a is equal to 0.05. A by 2 means it's 0.025 with n minus 2. N is 7 here, so 7 minus 2 is 5. So using this, we have to find the value for the t 0.025 comma 5. 5 is the degrees of freedom. So if you see the t table, they have given the degrees of freedom versus the significance level alpha. Significance level alpha here is given by um, okay, for 0.025 we have to see 0.0255 it's 3.163. So that's the value for this, and if you substitute this value, the previous equation 0.189, that is beta plus or minus square root of 0.101 divided by 5 into it's n into variance of x into 3.163. This will get you, wait, let me calculate. Plus or minus 0.025, 0.189. That can be between 189 plus 0.214 to 0.164. But we don't have that answer in this, I guess. Yeah, so I think some mistake from the app side, I guess, because they have taken for 0.005. Anyway, I will just clarify it once, like with that particular person. So before going to the 8th question, like we have solved the 7th question now. Before going to the 8th question, let's complete the 9th question. So the closeness of the coefficient of determination R square. So coefficient of determination means um, how much of the data is matching with the linear regression line. Like for example, if it is 90 means I can draw on for you. If this is the line, if all the data are like this, and yeah, up to this much the data is matching with the linear regression line, but this much deviation from the actual, this is like this region is not under the linear regression, so it can be up to something around 70%. So if it is 90% means it may be slightly deviating from this, but apart from that it should be following the close to the linear regression line. So which means like least square is estimated the regression line. Whatever the least square means the error which was estimated is close to the estimated the regression line. It is following the regression line. So following this question, the eighth question was also same. If the coefficient of determination is equal to 1, we know like 1 means it's like it's completely all the data are matching this or coming close to the regression line. So then correlation coefficient is given by, so correlation coefficient means how linear the fit is. So if it is between 0 and 1, so okay, I will give you some example. If it is like this means the correlation coefficient is something between 0 and 1. If it is something like this means it is between minus 0 and 1. Sorry, 0 and minus 1. So if it is like this perfectly means it is 1. If it is having negative, sorry, it is having the negative relationship means it is minus 1. So similarly, so if it is 1, it is following the linear regression line. It can be minus 1 or it can be plus 1. So it can be any value between, okay, sorry, it can be either minus 1 or plus 1. That is the answer. Okay, going to the 10th question, the last question. So if there is a quantity x, it's related to the degree of, design of experiments. There is a quantity x measured by conducting 3 different experiments in 5 different boundaries. So number of experiments is 3, number of labs is, okay, here they are, number of experiments n is 3, n lab is 5. So they are asking us to find the degrees of freedom of the sum of the squares of x within the laboratory and between laboratories. Okay, if it is within the laboratory, it is very simple. It's number of um, measure minus 1. So because like as we all know, like if um, we have all the datas, the one data can be easily, if you know all the, if I take 10 data, if I have reference for 9 data, one data can be easily sorted, it can be easily find it out. So that one degree of freedom is what to say, not that much required. So so similarly, like if it is within the lab, it is a number of measure minus 1. So here in this case, it is number of measure is in each lab. Degrees of freedom within lab. So okay, first we'll see degree of freedom okay, within labs means it's first what they are asking within a laboratory and between laboratory. Okay, sum of the squares. So number of measures is 2, 3 minus 1, 2. And degrees of freedom between labs is n into, what is n into 2, number of labs is 5 labs, then 5 into number of measures is 3 minus 2, so 3 minus 1 is 2, so 10. So we don't have 10 comma 2 answers. We don't have, yeah, just a moment. We just check it once. They take it in opposite sense. Context measured by conducting 3 different experiments in 5 different laboratories. So number of experiments is 3. Number of laboratories is 5. Quality is measured. whatever I have referred, I think I'm getting is in Laboratories 2 in between Laboratories 10. Everything will be done. So let me check and next time I will report what made this difference between the answer given. Answer given is 6,3. I'm getting answer which is completely not provided here. So let me check and discuss in the next. Or in between, I will put this answer in the ask the question section. Okay, that's all for this session. I think other questions I have solved it. So if you have any doubt, just write to my mail ID. So we can discuss further. So it is okay. So with this we close this session.